Okay, everybody, so we're going to graph some quadratics now. So first example I'm going to use is y equals x squared, where x is between -3 and 3. So if you saw the PowerPoint, my first step I told you to do was to draw a table or calculate a table of values for x and y to be able to get some points to graph on the axes. So our question has told us that our limits are between -3 and 3. So our values of x are going to be -3, -2, -1, 0, 1, 2, and 3. So squaring all of these, -3 squared is 9, -2 squared is 4, -1 squared is 1, 0, and then 2, 4, 1, 4, and 9. So there are our coordinate points. So for when x is -3, y will be 9. So we need to draw an axis now. And I'm just going to draw it so I don't really need any negative y values. And the scale will be 1, 2, 3, -1, -2, -3, and here is up to 9. 1, 4, 5, 6, 7, 8, 9 at the top. It's a bit messy. So writing things a bit hard, so it's going to take me some practice to get super neat. Yeah. So once we've got our scale, we can start plotting our points. Okay, so at -3 and 9 is a point, so x is -3, y is 9. At -2 and 4, right there. -1 and 1, right there. +1 and 1. Don't forget 0, 0. 2 and 4 and 3 and 9. So once we've got our points on, we can just connect, play with a nice smooth line. I'm not very good at it. Stopping at our end point there because we've been given this limit here. So once we've drawn our curve, this is a positive parabola, we can just label there our turning point, 0 and 0, and my axis of symmetry is that x is equal to 0. So it just means that at x is equal to 0, so here, if I was to draw that line straight up, my curve should be completely symmetrical on each side. So that was a mirror that we put down at x equals 0 or along the y-axis there. Our curve should be identical on both sides. So what about, let me clear this. What about an example, y equals 5 minus x squared. This is slightly different here. This time we've got a minus x. So have a think about what that might do to our curve. So before we had a positive x squared, and we had a curve like that, like a smiley face. This time we've got a negative, but we've also got it's going to be transposed here by 5. So knowing what we know about graphing, what we did with linear, what could that possibly happen here? What could that 5 possibly mean? So I know at the moment we haven't covered it yet, so not too much to worry about if you automatically don't know what the 5 will do. That's why we do a table of values. So our same limits here of -3 and 3. So x is between -3 and 3. And we're going to draw our table of values for x and y. And so just sub all our points in. -3, -2, -1, 0, 1, 2, and 3. We're subbing -3 in, we get y will be -4, 2 in, y will be 1, -1, y is 4, 0, y will be 5, and 4, 1, and a -4 again. So if you notice here at x equals 0 is our highest point, and then we get the opposite values for positive values of x as we did to the negative values of x. Okay, so now just drawing my axes. Wonky. Y and x. So I need my highest point up here is 5, 4, 3, 2, 2 and 1, and 1, 2, 3, 4, and 5, -4, -3, -2, -1, just negative, not decimal. And then I just need 1, 2, 3. And plot our points like we did with the previous example, which is kind of here. So at x is -3, y equals -4 is about down here. X is -2, y is +1, which is here. So x is -1, y is now +4, which is there. 5 and a turning point. 1 and 4, 2 and 1, and 3 and -4. And again, just connect your dots in a nice, smooth curve. Now, turning point there is at 0, 5, and my axis of symmetry is equal to 0 again. So the y-axis there is our axis of symmetry. Now this one, when we had a negative x value, so if x is negative x squared, we get a third parabola, an upside down one. So just something to remember to make sure you're plotting in the right way. If you've got a negative value for x, it's going to be the upside down or the frowny face, and if you've got a positive, it's going to be the smiley face. So I hope that was helpful, guys. Sorry for the very poor drawing. Hopefully I will get used to this pen.